start you off with a couple of them, and then I'll let you go in your group to see where you go. All right. Let's start. Actually, you know what? I'm going to skip over 1 because I'm going to let you and your group discuss 1. Let's go right to 2 right now. All right, let's go right to 2. X is referring to the chord length, everybody. X is referring to the chord length. So let's look at what we have here. We have an arc measure of 120. What's this 12 acting as? It's my radius, okay, and I need to find how long that chord is somehow. Now, do not be afraid in these diagrams to draw something else that may help you out. You said, what was the 12? Radius. So if I draw any other radius in that diagram, what's this length going to be? 12. Okay. Is there another radius I could draw in that might help me out? Is there another radius that may help me out? And where is that radius you could draw in? Third side of the triangle. All right. I have 2 sides of a triangle right there. I might as well make a third side because I know how long it is. It's 12. Now I start thinking to myself, all right, I got 12 and 12. What type of triangle is this? It's isosceles. And what do we know about isosceles triangles? I know 2 sides are congruent. 2 angles are congruent. Specifically, these 2 right here. But would I need an angle to find those? Now I'm going to try to pull a circle fact out of you. You do know an angle in that triangle, and what is it and why? What is one of the angles in this triangle and why? This is something we have going over, Ella. Central angle is 120, because remember, how do you find a central angle? It's the same as its arc measure, all right? So if I were to draw this triangle out a little bigger so we can see what the heck we're working with, I got a 12, I got a 12, I got an X, I have 120 degrees. Can you find the other 2 angles now, knowing it's isosceles and those 2 angles are congruent? What are we looking at? These 2 angles would be 30 and 30. All right, where am I going with this? A couple units ago, I'm giving all 3 angles a couple sides, and I'm missing a side. Any one of these that I've given you for formulas we could use. Because why isn't Pythagorean theorem going to work here? It's not a right triangle. Get over it. All right, but remember, law of sines and cosines I can use on any type of triangle. It's actually both I could use. I could actually use both here. Anybody have a preference? Law of sines. All right, let's use law of sines. Side over angle equals side over angle. Fill out one side of it for me. Fill out one side. Here you go, 14. Fill out one side for me. Side. Over. Be careful. Sine of 30. Good. 12 over the sine of 30 equals, here you go. What should I put? 11 on the other side. X over sine 120. All right, use 2 circle facts there, and then had to break out a little law of sines to finish it. Answer rounded to the nearest 10th when you get to it. We're cross multiplying. And nearest 10th, what do we end up with here? 5, what do you end up with? What is it? Sorry, I didn't hear it. 20.8, yep. Questions, comments? All right, I will give you an opportunity in your group to do 1. I will also give you an opportunity to do 3 in your group, okay? I want to go through a couple here, though. Here, let's get to 4 right now. All right, let's get to 4, everybody. Find the radius and the measure of arc AB. Measure, meaning it's got to be in degrees. All right, got to be in degrees. All right, so let's find a radius first in number 4. Problem, or any radius drawn in? No, okay, so let's make a good guess here. Where should I put in a radius that I can maybe find here? All right, because you can draw it anywhere. Frank, where's one radius I can draw in? Name a segment that would be a nice radius. CB. All right, let's draw it in. All right, I know one side of this right triangle is 5, but I don't know the other side. Is there a theorem that could help you out from yesterday? What did the theorem say? I got part of a diameter that's perpendicular to this chord. What's happening to this chord? It's getting bisected, yes. So if that's 5, that's 24, that's 12. And now how easily could I find the hypotenuse or the radii? Pythagorean theorem. Yep. 5 squared plus 12 squared equals radius squared, or c squared. And you guys are finding it. How many feet? 13. All right, this is the tougher part. Find the measure. So how many degrees are in arc AB here? That's what I'm looking. Not how long it is. How many degrees are in AB? One way you could find it is to the arc length formula, right? That has measure of, everyone remember the arc length formula. Arc length equals measure over 360 times circumference. But what's the problem? What's the problem using that formula? Anybody know the problem? I don't have the arc length to plug in. All right, so I don't have arc length. Okay, I'm going to let you dig deep. If you need to talk over with your group, talk it over. Other way you can find the measure of the arc. The measure of the arc is always equal to blank. The measure of the arc is always equal to blank. And what are you guys saying to each other? It's always equal to the central angle. What would be the central angle here? Even though it's not fully drawn in, what would be my central angle up here for arc AB? Angle ACB will be the same as the measure of arc AB. Central angle is equal to the measure of arc, yes. So you and I right now, we're going to come up with a way to find that angle right now. So I'm going to finish it, draw in radius AC. How can I find angle ACB? Well, let's draw out the triangle so I'm not looking at the circle and the triangle together here. Here's A, here's C, here's B. The chord AB was 24. CB was 13 we just found. What about AC? AC is also 13 because all radii are congruent, and you're trying to find that angle right there. And again, this is why I gave you those formulas before. Anybody know which formula would be appropriate here to try to find the angle when I know all 3 sides? All 3 sides. What formula would be appropriate here? Side. Law of cosines, yes. I cannot use law of sines because law of sines you need 2 angles. All right, but law of cosines you can have all 3 sides. So here you go. A squared equals B squared plus C squared minus 2BC. It's been a while, so this is why I'm here reviewing it with you. Anybody remember what the first side you plugged in was? First side you plugged in. 13, 13, or 24. Anybody remember which one we needed to plug in? The one across from the angle we're working with. If we're working with angle X, what's the side across? 24. So 24 squared equals other 2 sides. 13 squared plus 13 squared minus 2 times 13 times 13 times the cosine of X. $169 plus 169 minus, not too sure what those numbers are. 576. 338. When working with this, do you remember, can I combine all three of these? Can I do 169 plus 169 minus 338? No, I cannot. I cannot touch this right here. I can combine 169 and 169, but that's it. I cannot subtract 338 from it. All right, since I can't subtract the two, what do I do from here now? You guys are taking over. What do I do from here now? Let's go 11. What's the status from here? Yep. And you end up with 238 over here equals, don't forget the negative sign, negative 338 cosine x. And then from here, keep it going here, number 23, keep it going. Yep. You get a decimal, you can turn it back into a fraction if you want. Whatever that happens to be. That's not my angle though. One last step to find the actual angle. One last step. What did I do with that fraction decimal? 5, what did I do with it? Darn right. Nice job, man. X is equal to the inverse of cosine of that decimal. Or fraction, however you left it. And we're looking what, nearest 10th for the arc? Nearest 10th, 8, nearest 10th. Yep, if you don't have 134.8 degrees, make sure your calculator's in degree mode. Okay, never should come out of degree mode. Any issues? Yes, Skylar. How did I know A was what? Because in law of cosines, the A squared the A value is always the side across from the angle you're working with in the problem. I was trying to find angle C, so I looked across from angle C, and that was the side across. Okay, B and C are the other two sides in law of cosines. Okay. Other questions? All right, here you go. You're trying out now. Here you go. Just jot the answers down, so in case you and your group can't get the answers, you can call me over. Number 1 should come out to be 4.5. All right, 4.5. Number 3 should come out to be 13.7. On number 5, the radius should come out to be 6.7. And the measure of the arc should come out to be 53.1. All right, questions, comments? Okay, if you get done and get those answers, go on to the proofs. See what you can do with the proofs. If you finish the proofs, call me over. And so I can take a quick look at them. All right, let's get going. Work with each other in your groups. If you cannot get those answers, call me over. I'll help you out.